Hi students, Mr. Myers here. I wanted to provide a help video for you regarding delta H. Alright, so we have been talking in class about how to solve for delta H, specifically using the standard formation values. Okay, there we go. So using the standard formation values, which you find in Appendix 3 in your course pack, which is pages 79 and 80. Okay, and so we've got our reaction here, which I'm going to show a little bit bigger. CS2 liquid plus 3 oxygens, which is a gas, yields CO2, also a gas, and 2 SO2s, okay, sulfur dioxide. And in the sheet that you had this practice problem on this week, it gave you values for each of these substances. For CS2, we said is a liquid, its value is positive 177.4 kilojoules per mole. Okay. For oxygen, remember when it's an element in its natural elemental state, its value is 0. Carbon dioxide gas is listed at negative 393.5 kilojoules per mole, and SO2 gas is negative 296.8 kilojoules per mole. Okay, so before we go and solve the problem, I'll change the color here because I want to remind you how we go about solving it. Remember that delta H is equal to the sum of the delta H values for the products minus the sum of the delta H values for the reactants. Okay, so we're going to do this side here, the products, first, and then we'll come over and do the calculation for the reactants. That did not like my R. There we go. All right, so for the products, we're going to do the following. Delta H equals, we've got 1 carbon dioxide, and so we'll do 1 times negative 393. Remember, this 393.5 is kilojoules per mole, and because the coefficient here is 1, we're effectively seeing that 1 mole of CO2 times this negative 393. So those moles right here would cancel. So we've got negative 393.5 plus the value up here for the SO2, and we have 2 of them. So we'll do 2 times negative 296.8. Okay, so that is the product side. And then we carry on with the reactant side, where we have 1 of the CS2s, which is a positive 177.4, plus, and we have 3 oxygens, but remember the oxygens are 0. So we can write 3 times 0, or we can leave it out, or just put 0. Okay, it doesn't get counted up in there. Okay, so as you go through to calculate, we carry it down. Some of you are doing a good job already of doing this right in your calculator. Just straight left to right, right through. The way we've set up with these brackets, you can do parentheses here and just do all the way through, and you should be okay. Okay. If you like to break it up between each part, I'll do that real quick with my trusty calculator. So we've got that 1 times the negative 393.5 plus 2 times negative 296.8. Okay, that part here is negative 987.1 minus, and then we've got that 177.4 hanging around. There we go. So this delta H, we've got that value minus 177.4, and that gives us a result of negative 1164.5 kilojoules. Okay, so this is our value, negative 1,164.5 kilojoules, and because delta H is negative, we can say with full confidence that this is an exothermic process.